precipitate, then that is not all solutions. Whenever we mix two solutions, we get PPG. No, not necessary. So when we mix two solutions and if we get a insoluble solid, then we say it as precipitation reaction. So we have one is this AgNO3, or we have AgNO3 then HCl, or we saw that what is that, ferrous sulfate reacting with this one, NaOH. So we get FeOH twice, and we said that it is dirty green precipitate. So then now when we go to lab and see, we will be more clear. Now if we see the next one, which is the next one. Now coming on to reactivity series, we have already done. I hope now we all remember what is reactivity series. Yes. So you all know that mnemonic. Please stop calling that, And why we want reactivity series? For which reaction are we using reactivity series? For displacement reaction. Displacement reaction. Correct. For displacement reaction, we are using reactivity series. So based on that, already we have discussed, but then just jotted down few points. That is arrangement of metals in a series in descending order of the reactivity. Descending order. The top one is very reactive and the last one is least reactive. So it is descending in its reactivity. So that is how it is arranged. Which is the which is the element on the top, that is potassium. So it is most active, and the last gold, platinum, they are the least. Yes. Now metal which is at the top of the series displaces metal lower in the series. Yes or no? Yes or no? Just a minute. So displacement we have seen, if zinc is reacting with HCl, so zinc top, H at the bottom, towards lower end. So zinc can displace hydrogen. That is what we have seen. Then hydrogen, though not directly a metal, is listed for comparison. Now this is the reason. Last time also, like few had queries also when we discussed this. Why hydrogen, being a non-metal, why hydrogen is there in the series? It is just for comparison. Okay, just for because H comes in acids, and when reaction takes place with acid, so we should be aware whether this metal can displace H or not. So that's the reason, that is why it is kept in the series. Metals above hydrogen can displace hydrogen ions from acid alkali. So just now we said H2O hai, HCl hai, alkali. So that is the reason why we have kept H in the reactivity series. The one which is below hydrogen, we know it cannot displace hydrogen. So this is about the reactivity series. Now coming on to the next part, very small part. These next two are very small. Just you need 2 lines or 3 lines of it. Oxides and its classification. Now what is oxide? This we already know. Binary compound. Why is it called as binary compound? Because it is having oxygen, and oxygen cannot live alone. So 2 molecules. O2, it's an O2 form. It has charge -2, correct? As anion. Charge -2 also, yes, right. So oxide, it is a binary compound in which oxygen is present as an anion. Anion means positive or negative? Negative. Negative. So O -2. So minus means anion and charge is 2. Oxygen atom is highly reactive due to its small size. Now this you will slowly learn in basically in 10th standard. So it is like when you have elements arranged in the periodic table, the one which is towards the right, they all are very small in size. If they are small in size, then the reactivity is more. So smaller the atom, more is reactive, because it is known that when the atom is very small, they can accept many electrons. Small, so it can accept many electrons. And many electrons means they become more reactive. So oxygen atom is highly reactive due to its small size. Why is oxygen atom highly reactive?
As its outermost shell is having 6 electrons.
That is 6 electrons, and due to its small size. Okay, so then it combines with the metals and non-metals to form oxide. Means what? Oxygen can combine with metal also, oxygen can combine with non-metal also. Now you know very well to identify which element is metal or non-metal, right?
Yes.
If you know the electronic configuration, then last shell should have how many electrons for that? 8. I'll repeat. Listen the question. When we write electronic configuration, what is electronic configuration?
Number of electrons
present
in an atom of a molecule.
Right. So that means a 2, 1, 281, 282, 287. That is electronic configuration. Now, if you know the electronic configuration, from that, which number you are going to see to check whether the given element is metal or non-metal? The valence shell is metal. In the valence shell, how many electrons should be there?
8 octet rule.
8 should be there if it has to be a metal.
1, 2, and 3. 1, 2, and
1 or 2 or 3 electrons in the outermost shell, then it is a metal. And 4, 5, 6, 7 in the outermost shell, it is a non-metal. And last shell में 8 electrons, then it is
noble gas.
Noble gas. Right. This is how we are identifying metal and non-metal. So here oxygen atom is highly reactive due to that's done. It combines with metal and non-metal to form oxides. So this oxygen, like sodium, it forms with Na and sodium. So it will form sodium oxide. Sulfur is a non-metal because last shell में 6 electrons है. Sulfur is the non-metal. That non-metal combines with oxygen to form sulfur oxide. Okay, so S with O. Carbon is a non-metal. It combines with O to form carbon monoxide, carbon dioxide, like that. So based on that, there are few types of oxides based on their nature. Now you should be very clear whenever we say acidic oxide, acid, base, neutral, these all are nature or the types. Okay. Types of oxides are 4: acidic, basic, amphoteric, and neutral. What are the 4 types of acid? Acidic, basic, amphoteric, and the 4th one is neutral. Let us see what is acidic oxide. Now, acidic oxide. First thing what you remember is the word is acidic oxide means we are learning about oxide. So oxide ka some compound is going to give us acid. Okay, oxide of some compound is going to give us acid. So that is what is acidic oxide. So which element has to get attached with oxygen to give acidic oxide? So the keyword is non-metal. Non-metal है ना? See, if you see the example, S, C, N, they all are non-metal. Sulfur is a non-metal, carbon is a non-metal, nitrogen is a non-metal. So these non-metals, when it reacts with oxygen, sulfur with oxygen, nitrogen with oxygen, carbon with oxygen. So when they react with oxygen, it forms oxide. And that too, how are they forming oxide? By sharing through covalent bond. Electron. Through covalent. Electron nahi, covalent. Covalent is sharing. Okay, so sharing, this also we have studied. Covalent means covalent is formed by sharing of electron. So the sharing takes place between which metal, non-metal?
Metal and non-metal.
Non-metal and non-metal. Yes, sharing takes place between non. Now if you see sulfur is a non-metal. Yes or no?
Yes.
Oxygen is a non-metal?
Yes.
So non-metal, the bond formation takes place by sharing of electrons. Okay? So this, so understood, no? Any non-metal with oxygen forms oxide. Which oxide? Acidic oxide. or in simple terms we say non-metallic oxide. So don't forget, non-metallic oxide and acidic oxide is one and the same, just the names are different. How we wrote combination reaction is also called as synthesis reaction. Same way acidic oxide is also called as non-metallic oxide. Next, they have, because they both are coming under non-metal, so they have very low boiling and melting point. So these are the examples. Now the last sentence is why we have given the word acidic oxide. Otherwise we could have simply told non-metal with oxygen gives non-metallic oxide. So then why we gave another name acidic oxide? The reason is here. When acidic oxide means non-metal oxide react with water, that means this sulfur dioxide with water, sulfur trioxide with water, carbon dioxide with water, nitrogen dioxide with water, any of these with water gives us acid, and that's the reason why the name came up acidic oxide. If you see the example here, this is SO3 means sulfur trioxide. If it reacts with water, forms H2SO4. Last time in some class, they were asking about acid rain. It was D division. Acid rain. So there also what was discussed, acid rain means in the atmosphere there are gases. Now gas means what? Carbon dioxide, sulfur dioxide. These all are gases present in the atmosphere, right? Now where there is large, means that gas intensity is very high, in higher percentage this gas is present, and when the rain comes, now that means what? See, SO3, SO2, CO2. So this is already present in the air, plus water means now the rain is falling down, that means plus rainwater gives you acid. So then whatever comes down is nothing but acid. So in short we can even say gases not all sorry, few gases when react with water gives acid. H2SO4 is an acid or not?
Yes, acid.
Yes, acid.
Sulfuric acid.
Sulfuric acid, right. Sulfuric acid. What is the formula of nitric acid?
HNO3.
NO3. Hydrochloric acid?
HCl.
HCl, right. Okay. So now if in place of SO3, if we had CO2, okay?
Carbon dioxide.
Carbon dioxide. So carbon dioxide gas with water will give which acid?
Carbonic acid.
Carbonic acid. What is the formula of carbonic acid? H2CO3. Yes.
H2CO3.
Right. So simple, very simple. Acidic oxides are very simple. First you are saying that non-metal is reacting with oxygen to form oxide. How is it, second point, how is it formed? Formed by sharing of electrons. Third, they have low melting and boiling point. Then example, and finally we are saying when this oxides, non-metal oxide, acidic oxide, combine with water, we are going to get acid. Acidic oxide gives acid. How they give acid? When this acidic oxide reacts with water. Okay, any doubt in acidic oxides, children?
No.
Okay. Next, moving on to basic oxide. Just ulta, just reverse of acidic oxide. Now, there we took non-metal oxide. Now we will take what?
Metal.
Metal. So this metal, when they react with oxygen, it will form oxide. Now here metal and oxygen is a non-metal. So metal non-metal
Electrovalent bond.
means electrovalent bond. And how is electrovalent bond formed? By
completely transfer of electrons.
yes, transfer of electrons. So metal with oxygen gives basic oxide, in simple terms, metallic oxide. Okay, by transferring of electrons. They have high melting and boiling point because it's a electrovalent compound, so definitely they will have. Electrovalent compound means the force between the particle is very strong, so they have high melting and boiling points. Here example are calcium oxide, iron oxide, sodium oxide, zinc oxide, so many. Now tell me children, Ca, calcium is a metal, no?
Yes.
And oxygen is a non-metal. So metal, non-metal. Fe is a metal, oxygen non-metal. Sodium is a metal, oxygen is a non-metal. So that is why there is transferring of electrons. Now here here, why are we calling it as basic oxide? Metallic oxide name is there, still we are calling it as basic oxide. Now why? When basic oxide, so example is suppose Na2O. When basic oxide reacts with water, again
It forms base.
it forms base. So how do you identify this as base?
There is OH.
OH, very good.
OH.
Right. So NaOH. So this Na2O, which is metal oxide, but that is also somewhere base. Na? Oxygen hai na, so base. Reacting with water, you are getting NaOH. So tell me, NaOH is alkali or base? Insoluble base.
Alkali.
Sorry, ma'am, can you repeat?
NaOH is an alkali or an insoluble base. What is it?
Alkali.
Yes, NaOH is an alkali. Okay? Because it is I said no, very few alkali like NaOH, KOH.
Answer
sorry,
correct. తుక్క
So,
పిక్క కాదు
basic
నేను
oxide.
రాసుకొని
So, isn't it
పెట్టుకున్నాది
the reverse of acidic oxide?
నీ
Totally
ముఖం.
reverse, no? There non-metal, here metal. Sharing of electron, transferring of electron. Low,
4 points for distinguish.
yes. Low melting and boiling point, high melting and boiling point. Here acidic oxide with water gives acid. Basic oxide
దాని
with
పైన నేను
base
చెప్పిన
gives
ఆలు నిమ్మలంగా
sorry, basic oxide with water gives base. And one example. So this is all about basic oxide. Next, coming on to amphoteric oxide. Again,
These are both properties of acidic also and base also.
yes. So acidic, the amphoteric oxide means this oxide. Suppose I am amphoteric oxide, so I will act as both acid as well as base. Now, how does it happen? Because it is having the property of acid as well as base. So, if I am reacting with an acid, okay, so here already acid is there. So, what will be my nature now? My nature will be as base because already acid is there, right? So, acid now. This amphoteric oxide is taking the property, now it will show the property of base. So base plus acid gives what? Forms what?
Neutral.
But what? So on reaction of oxide, which is acid or base, neutralization takes place and forms dash and dash.
Salt and water. Form salt and water.
Correct. Neutralization. Yes. In neutralization, acid plus base gives salt and water. Now suppose I'm amphoteric oxide.
మూసుకోండి.
Here now I am taking base. I have to react with the base. So I am acting as what?
Acid.
Yes. So I am acting as acid now because I have to react with the base. So acid plus base is salt
And water.
Understood? Now, if I am acid, this is base. It's other way around. If I am taking a base, immediately my nature becomes acid. If I take acid, immediately the amphoteric oxide, the nature becomes base. So that either way, when you react, it gives salt and water. So there are compulsorily three main you need to remember: aluminium oxide, zinc oxide, lead oxide. Which are the three amphoteric oxides?
Aluminium oxide, lead oxide, and lead oxide.
Use the word oxide, children. Otherwise, you will simply write the metal. Metal is not amphoteric. वो metal का जो oxide है, suppose zinc. Is zinc amphoteric? No. It is not amphoteric. Zinc oxide?
Yes.
Right. Zinc oxide amphoteric. Zinc not amphoteric. Same with lead oxide amphoteric. Aluminium oxide amphoteric, like that. It's hydroxide also, children. Hydroxide is also amphoteric. Now see the difference. In the first reaction, I have taken which oxide?
Aluminium oxide.
Second reaction, which oxide I have taken?
Zinc oxide.
Second reaction, aluminium oxide only. In both the cases, I have taken aluminium oxide. But see the reaction with what is it reacting? So aluminium oxide is reacting with what? NaOH.
Sodium hydroxide.
What is sodium hydroxide? Acid or base?
Base.
Because he have taken. Now NaOH I am going to add it to Al2O3. So this Al2O3, which is amphoteric oxide, is acting as base.
Of aluminum.
Base? Acid.
Acid.
So understand properly. Either NaOH is base, so Al2O3 will be acid. Now HCl is what? Acid or base?
Acid.
It is acid, so Al2O3 will be base. It is acting as base. So this is how amphoteric oxides are. If with what is it reacting decides the key amphoteric and actual will be what. Now if you see Al2O3 plus NaOH is giving you NaAlO2, sodium aluminum.
Sodium aluminate.
The salt plus water. Same way Al2O3
Aluminum sulfate.
Al2O3
Aluminum oxide.
aluminum oxide. HCl acid.
Hydrochloric acid.
Hydrochloric acid. So these both will combine to form
Al2SO4.
Aluminium
sulfate.
Sulfate nahi. How sulfate?
Chloride.
HCl. I have taken different examples in textbook. Textbook it is H2SO4. Al2O3 plus HCl gives you AlCl3.
Chloride.
Yes. So aluminium chloride is salt and water. So this is all about amphoteric. So amphoteric oxide, what you have to remember that the amphoteric oxide is behaving both as acid as well as base. Hence, this reaction, when oxide ka reaction is taking place with either acid or base, it is definitely going to give us salt and water. Means what? Amphoteric undergoes which type of reaction? Neutral reaction. Okay, neutralization reaction. Then two examples we need to do. Last one is very simple, nothing. Just you need to do one sentence, an example. Neutral oxide. As is the word is neutral, so nothing to do. Okay, no nature, acid, nahi, base, nahi, so reaction and all. So these oxides do not show either an acidic or basic properties. So example is carbon monoxide, nitric oxide, or you can tell it as nitrogen monoxide and nitrous oxide, dinitrogen monoxide. Anything you can say. So which are the three main examples of neutral oxide?
Carbon monoxide, nitric oxide, and nitrogen.
Yes. Don't get confused with NO and NO2, N2O reaction. What is NO2?
Nitric oxide.
NO2.
Nitric oxide.
Okay, 1 minute. What is CO2?
Carbon dioxide.
Carbon dioxide. What is SO2?
Sulfur dioxide.
Huh?
Sulfur oxide.
Sulfur dioxide. CO2 is carbon dioxide. SO2 is sulfur dioxide. So NO2 will be
Nitrogen dioxide.
Nitrogen dioxide. Nitric dioxide, nahi, nitrogen dioxide. But here what we have written, have we written NO2 or N2O? N2O. So it is not nitrogen, it is nitrous oxide. या फिर dinitrogen, because there are two nitrogen and one oxygen. So dinitrogen monoxide, like that also you can write. Or simply studies as nitrous oxide and NO is nitric oxide. Clear? So neutral oxide, there is nothing, very simple. Last part of the lesson is forming oxides of metal from their ore. You don't know what is ore?
Yes.
Ore. What do we get from ore?
Metals.
Metals. We get metals, right? And if you remember, I told like this ore, when we have the process of ore, then sorry, I didn't tell you. Sorry, I didn't tell you. Sorry. I got confused with 9th standard. Ore. Ore, it contains minerals, whatever main element ka mineral is. Mixture. It has all mixture of many things. So from that ore, we have to remove. Like for example, zinc ore, ZNS suppose. Yeah, bauxite ore. So many writing in like fourth rotation. Yes. So zinc ore, oxide of metal. So how are we converting ore to oxide? Yes?
ore for lead.
Yes. We have PBS, galena.
Galena.
So, this in that metallurgy process, we need to. There is one step where you need to get its oxide. Okay, ore is in all combined form, either carbonate form or sulfide form. Some kind of form where this ore is present. From that ore, now we want to convert it into its oxide form. So that is what we are. That step is what we are studying here, forming oxide of metal from the ore. So there are two ways: calcination and roasting. What are the two ways?
Calcination and roasting.
Calcination and roasting. Now here again you can get distinguished between calcination and roasting. That kind of question can be asked. What is calcination? Calcination, the first word, decomposition reaction. This is very important. So calcination is following which type of reaction? Decomposition reaction. So decomposition reaction, where what happens? A metal ore. So here the metal ore is zinc carbonate. We know that if it is decomposition reaction, reactant side should be 1 and product side should be more than 2 or more than 2, right? That is what is decomposition.
Yes.
So here now see, there are two, calcination and roasting. That means some type of ore will use calcination method, some type of ore will use roasting method. Okay, so calcination method may we use decomposition reaction. Decomposition. Now here what happens? What is decomposition? Zinc, copper, magnesium, they all are in its carbonate form. Zinc carbonate, copper carbonate, magnesium carbonate. ठीक है, carbonate form में ore है. This ore we will have to heat. You have to heat.
Limited supply of air.
But what is the condition of heating? You should give very less supply of air, almost, or absence of air. So that kind of condition has to be created in the furnace. Okay, that kind of condition. Either very less or absence of air. So what will happen? This suppose zinc carbonate is taken. Now we are heating it. So heating में minimal oxygen is always there, because heating process means oxygen is there, but that oxygen is kept at very less amount. And now when we heat it, this zinc carbonate decomposes, forms zinc oxide and carbon dioxide. So did we get metal oxide from ore? Yes or no? Zinc carbonate means we got zinc oxide. Same way if I am taking copper carbonate, what will I get? Zinc carbonate. Yes, I got zinc oxide. So
Copper oxide. Copper oxide.
Copper oxide. If I take magnesium carbonate, I will get
Magnesium oxide.
magnesium oxide. Yes. So that is what is calcination. So in calcination, sorry, anyone had some doubt? Yeah. This process is used in metallurgy. Metallurgy, where there are 4 main processes. First process is simple cleaning, out of which one you had studied, no? Fourth flotation. You remember? Fourth flotation we have studied?
Yes.
So one is simple cleaning. Second is the one which you are studying now. Ore, that cleaned ore, so we have to convert into its oxide form. Third step is this oxide which we got, like zinc oxide, copper oxide, they are converted to metal. Yani ki zinc oxide will form zinc, copper oxide will form copper, magnesium oxide will form magnesium. That is third step. And last step, we will clean the metal, purify the metal. Okay, so that is what is the steps that you need not remember now. What is so calcination? First, what is the keyword? This is the first keyword.
Decomposition.
Decomposition
Reaction.
Yes. This is the keyword, decomposition reaction. Here what is happening? Are we heating? Huh? Are we heating?
Yes.
Yes.
It is
It is heated, but in
limited supply of air.
limited supply of air or absence of
Absence of air.
and it gives carbon dioxide and water.
But teacher, without the absence, in the absence of air, how can it be heated?
Yeah, send out.
Yes, we can heat it. That's what I said. See, the heating process itself involves a minimal oxygen. Only that much. You are not giving extra supply of oxygen. That is what is the meaning of calcination. Now, when we see roasting, you will understand the difference between the reaction. Now here,
Roasting is done at very high temperature.
here zinc carbonate, you are not giving heat. Heat means what? You are not giving any extra supply of air. Within that limited may we are heating it. That's why it's limited. Okay. Now see at the same
Parametric presence of air.
now at the same time roasting. What is roasting written? It is a process in which ore is heated, but it is in presence of air at high temperature. Now here down you see the reaction. Here the reaction, in this reaction, plus, oh, I wrote plus somewhere else. Now if you see ZNS, here we have written plus oxygen. Means here we are again adding oxygen. Getting it? In the previous reaction, did we see plus O2?
No.
Yes.
You saw? Where can you see?
No.
No. Zinc carbonate did we add extra oxygen?
No.
Oh. But at the same time, roasting, we are adding oxygen?
Yes.
So this is the difference. Roasting, we have to have oxygen supply in it, but in case of this one, what is that? Calcination, you don't need any extra oxygen, whatever presence may, because it's very fast. The decomposition is very fast. So you don't need any extra oxygen to be passed in to complete the process. So here the process is heat. Here ore ko strongly heat karo, and how? In presence of air at high temperature. Which type of ore? There we took which type of ore? We took all what?
Carbonate.
We took all carbonates. Here what are we taking?
Carbonate.
Sulfide.
Magnesium.
Sulfide ores.
Which one? Sulfide ores we are taking. ZNS, PBS. Okay, here we are taking sulfide ores. Here we took the carbonate. That's a major difference, because when you write the reaction, it shouldn't happen that you go wrong, get confused. So roasting, maybe take sulfide ores, and calcination, maybe take which ore? Carbonate ore. So here we are taking ZNS, so it's reacted with oxygen, forming ZNO plus SO2. And it is conducted in a furnace. What is the name of the furnace?
Reverberatory furnace.
Reverberatory furnace. What is it? Reverberatory furnace. Now what is the specific nature about this furnace is the heat that you are passing. Just a minute. You can see the diagram?
Yes.
If you see the diagram, this flame, the flame which we are inserting into that furnace, that flame is done towards the walls of the furnace. It is not directly, it is an indirect process. So it is not directly focused on the ore which is present. Rather, they are trying to heat the walls so that then that heat sufficient what is there, the walls may be jo heat produce over, that is also very important for the reaction to get completed. So this is what is reverberatory furnace. As such, you don't have to draw the diagram and all, but showing how that flame, see how the flame, it is not like we are not heating it from the bottom or like this. Now here we are giving an extra, not extra, the flame which is actually the flame is going inside. We are not heating it outside, and the heat is completing the reaction, but the flame throughout the walls of the container. So this is about roasting and calcination. So in calcination, oxygen is needed or not needed?
Minimal, in very minimal amount.
And roasting?
3 days.
Very, you need a proper amount of air at high temperature. Okay. In calcination, which type of ore are we taking?
Carbonate.
And roasting?
Sulfide ore.
Sulfide. Yes, says ZNSN. So, when you heat carbonate ore, what are the two products?
Carbon dioxide and water.
Carbon dioxide and
Carbon dioxide and metal oxide.
metal oxide. See. This carbon dioxide and water is the later part, the children after the process. But actually here what you get, here you get a metal oxide at first stage. So let us take the first stage because that's what you're studying here. It gives you carbonate you are heating, so definitely the gas evolved will be carbon dioxide. In addition to that, whichever metal ka carbonate you are taking, same metal ka oxide you get. If you have taken zinc carbonate, you get zinc oxide. Magnesium carbonate, you get magnesium oxide. And which gas is released? Carbon dioxide. In roasting, which are the two compounds formed as product?
Sulfide.
Which is a gas evolved in which is a gas evolved in roasting?
Oxygen.
Gas evolved. Oxygen that we are using.
Carbon dioxide.
Sulfide.
CO2.
Yes, Soham?
CO2.
I am asking for roasting. Children, roasting may be took sulfide ore. So, which gas will be formed?
Sulfuric acid.
Sulfur dioxide. What will be formed? Sulfur dioxide.
Sulfur dioxide.
In calcination, we heated zinc carbonate. So, which gas will be what? Carbon dioxide. In the roasting process, which ore we took? Sulfide ore. Correct? So will you get, can you see any carbon here?
No.
No, now you will get carbon dioxide. This ZNS is a sulfide ore. So when sulfide ore is reacting with oxygen, what compound you will get? Sulfur dioxide. So because such question can also be asked. In calcination, the gas evolved is carbon dioxide, and in roasting, the gas evolved is
Carbon dioxide. Sulfur dioxide.
Some of you all are very fond of carbon dioxide, so not ready to leave carbon dioxide at all. Huh? Yeah, whatever it is. Correct, no? Carbonates will release which gas?
Carbon dioxide.
Sulfides will give which oxide? Sulfur dioxide. Very simple. Make it simple for you. Don't make your life very complicated. Huh? Just by reading something in chemistry and making life complicated. It's very easy. Very, very easy. So I hope you all clear with the distinguish between. So calcination, first difference is this decomposition. One more question. Here we say that this is, which type of reaction is this?
Decomposition.
This one?
Double displacement.
What is this?
Displacement reaction.
Displacement. What is it?
No, there is only one in left side. Here is two there. This is double displacement, no?
Double displacement mein you need positive, negative, positive, negative. Here so we have positive, negative, and one is oxygen molecule.
Is it combination reaction?
It is combination reaction with a very little different pattern of combination where we studied that right side of combination should have only one product. Correct? We studied this, right? It should have only one product. But in this case, the thing is what? ZNS is a compound and O2 is a molecule. They are combining together. If you see, you cannot have displacement reaction because it is not as per the reactivity series. You cannot have double decomposition because we don't have two compounds. We don't have compounds. We have ZNS as compound and oxygen is what? Molecule.
Molecule.
It is a molecule. So
Molecule.
we cannot use, it's not decomposition. We cannot use displacement. We cannot use double displacement. So what is it? It is
Combination reaction.
combination reaction.
Combination reaction.
Understood? A different variety of combination reaction. Last time we studied that you get only one product.
Yes. So this can happen in only roasting case or other case also.
Yes, which basically if it's a molecule, like gases are involved with any compound. Okay, so that is one difference. Decomposition combination. Then the other one is calcination is in limited supply of air. Roasting is in
Highly.
yes, in presence of high amount of air. Here, calcination we take which type of ore? Carbonate ores.
Carbonate.
And roasting में which type of ore we take? In calcination, which gases evolve?
Carbon dioxide.
In roasting, which gases evolve? See, so many distribution between points we get in simple roasting and calcination.
One doubt. Both are done in river battery furnace only.
No. The type of ore, whichever type of ore we are taking and whichever extraction process, as per their process, the whatever apparatus you take, it will differ. Okay, for each it is different. If you are going for aluminium extraction, the aluminium extraction is totally different. If you go for iron, then iron ore like hematite ore and all, then there the whatever you are using, it is different. So for every ore, the things are different. Why? Because for every ore the requirement is different. For some case you need heating, some case you don't need heating. Some needs only electrical process like electrolysis and all. So some may not need. Some may need very high temperature like iron and all. It goes on with 1000, 2000 degrees Celsius. So there we use blast furnace. We use. So that is different type of furnace. So everywhere, as per the type of extraction what we are doing, the things are different. Okay. So here we complete the lesson. Now what is left out is only discussion of question answers. So next time when we meet, we will discuss the question answers. Okay. So I will see here there is no doubt, and there are a few markings also I'll give so that you are clear with what how you have to go about with the lesson. Not too much of reactions, then you will leave that lesson. I know. So we will limit it so that whatever you are studying is done properly. Okay, so it's 9, 8, 9:50. You have next lecture at what time?
9:30.
9:30. Okay, so 5 minutes early I will wind up. Next time when we meet, we will discuss the question answers. Okay, so till then.